It is widely believed there is no more profound discovery of 20th century science than the realization that our world's chemistry is created by nuclear processes in stars. The air we breathe, the ground we walk on, the food we eat, and our bodies themselves all are based in elements forged in the hearts of stars, and Palomar was central to this realization. Up until the 1940s, the origin of elements in our periodic table was mysterious. English astronomer Fred Hoyle had the provocative insight that stellar interiors could be hot and dense enough to create elements heavier than helium through nuclear fusion, but the suggestion was hard to verify. Stellar elemental abundance studies using spectroscopic methods were just becoming possible as the Palomar Hale telescope began operations, and Caltech astronomer Jesse Greenstein used the Hale to study the chemistry of nearby stars. Combined with similar observations made by other researchers, patterns emerged in the abundance data that allowed Hoyle and collaborators to develop a robust theory of what we know today as stellar nucleosynthesis. In 1957, the team of Margaret Burbidge, Geoffrey Burbidge, husband and wife, Hoyle, and William Fowler published the seminal paper that gave a convincing outline of how stars create the elements of the periodic table in their observed amounts. In scientific circles, the team and their research became so widely celebrated that we refer to them both by a modern-sounding acronym of their names, B²FH. Today we understand the life cycle of matter on Earth as originating in the cores of previous generations of stars that enrich the galaxy with heavy elements created over their lifetimes. Sometimes the enrichment happens spectacularly in the supernova explosions of high-mass stars, and sometimes more gently when low-mass stars like our Sun lose their outer layers in the late stages of their lives. These processed materials become mixed with interstellar gas that eventually form subsequent generations of stars and their planets. This process continues today, with astronomers using Palomar telescopes to discover hundreds of supernovae each year and to study nearby star formation. We owe our very existence to this program of cosmic recycling, and it is both wondrous and humbling to contemplate humankind's deep connection to the stars that light our night and our day.